Alright guys, in this video we are going to talk about how we calculate the pH value at equivalence points for a weak acid strong base titration. Take a look at this question. A titration of the 40 ml of 0.1 mole per liter of acetic acid, weak acid, with 0.10 mole per liter of the sodium hydroxide, strong base. Calculate the pH value at equivalence points. Kb value of the acetate is given here. This is the reaction equation that I need you to understand before you start your calculation. In this titration, acetic acid will react with sodium hydroxide to generate sodium acetate and water. Remember, when you reach the equivalence point, both reactants are gone, and you have this sodium acetate and water in the solution. As you know that sodium acetate is a basic salt, so our target actually is to calculate the pH value of this basic salt. Alright, so let's do this step by step. The first one, you need to calculate the volume of the sodium hydroxide needed to reach the equivalence point. Because by doing this, you will know the total volume of this titration. So you can calculate the mole number, you can calculate the molar concentration of the sodium acetate. Alright, and step 1, you can use MA VA equals to MB VB to do the calculation, because this is one-to-one reaction. MA 0.1 mole per liter times 40 ml, and you don't have to convert the ml to liter, because if we maintain the same unit for volume on the two sides, you can cancel the unit anyway. But it won't hurt you if you convert the ml to liter, and you will get the same answer. MB 0.10 mole per liter times VB. Okay. Alright, and if you do the calculation, VB would be 40 ml. Alright, 40 ml. Step 1. Step 2. Stoichiometry calculation to find out the mole number of the acetates at equivalence points. This is the equation that we need to do this calculation. Stoichiometry calculation, here is how we constructed the charts. We need to calculate the mole number before reaction, the change, and the mole number of those reactants products after reaction. Before reaction, the mole number of the acetic acid is 40 ml. Of course, you have to convert this one to liter in this case. Okay, so this is times the concentration, and that is 0.1 mole per liter. It gives me 0.004 mole. For sodium hydroxide, we do the same thing. The volume of the sodium hydroxide to reach the equivalence point is 40 ml, so 40 ml. Again, you convert that to liter, 1000 ml at the bottom, 1 liter, times 0.1 mole per liter, and that equals to 0.004 mole. Okay, before reaction, there's no sodium acetate, so it's 0. Now what's the change? Since both reactants have the same mole number, so the change would be 0.004 mole per mole for both reactants. And the change for sodium acetate is positive 0.004, because you are going to generate this much of sodium acetate. Now after reaction, you don't have any reactants, but you do have 0.004 mole of sodium acetate All right, so this is the mole number of the sodium acetate. But please remember, we are looking at the mole number of the acetate. Now we know the sodium acetate. How do we know the acetate's mole number? Here's the thing. Sodium acetate is a strong electrolyte. So when you dissolve that in water, it's going to give you acetate and sodium. Okay, 100% dissociation. So that means once you find out the mole number of the sodium acetate, you find out the mole number of acetate. So acetate, the mole number of the acetate is 0.004 mole. All right, now step 3. Remember at the very beginning we said we need to know the concentration of the acetate because this is a basic thought. Once we know the concentration of the acetate, we should be able to calculate the pH value based on the Kb value of this weak base. Okay, so here's the calculation of the concentration. You have the mole number of the acetate, 0.04 mole. If you know the volume of the solution, then you should be able to calculate the molarity of this basic salt, okay, or the weak base. You start from the 40 ml of the acetic acid, and you add 40 ml of the sodium hydroxide in it. So the total volume would be 40 ml plus 40 ml. Okay, of course you have to convert that to liter to do the calculation of the molarity. One liter. Okay, my calculation gives me 0.05 mole per liter. All right, so this is a concentration of, okay, let me write it here, concentration of the acetate is 0.05 mole per liter. Now the last step is to construct the IC chart to find out the concentration of the hydroxide, hydronium, okay, based on this weak base. Step 4, IC chart. IC chart is based on this equation. The acetate, dissociation of the acetate in water to generate the conjugate base, a conjugate acid, and hydroxide. IC chart, initial concentration. Okay. Initial concentration of the acetate, 0.05 mole per liter. Concentration for both of them are 0. The change and the equilibrium concentration, we don't know how much is dissociated, so set up x, x, x here. And so equilibrium concentration, okay, so that would be 0.05 mole per liter. 0.5 minus x, x, and x. So when you reach here, everything should look familiar to you. This is what we did in last chapter, okay, when we discussed the pH value, pOH value for weak acid and weak base. Now, when you look at this calculation, Kb of the acetate is 5.6 times 10 to the negative 10. That equals to x squared over 0.05 minus x. Approximately, because x is very small, so that it would be x squared over 0.05. Okay. If you do the calculation, x would be 5.29 times 10 to the negative 6 mole per liter. Okay, so based on our assumption x is very small, we got a value for x. Of course, you have to do the calculation to check whether this assumption is good or not. So 5.29 times 10 to the negative 6 mole per liter divided by the initial concentration 0.05, you calculate the percentage of the x versus the initial concentration. I got 0.01%. It's less than 5%, so our assumption is good. Now, when you look at this, x is this much, and concentration of the hydroxide is x. So if you take the negative logarithm of x, that is a pOH value, 5.29 times 10 to the negative 6 mole per liter, okay, that equals to 5.28. And based on this, the pH value equals to 14 minus 5.28. And that is a 8.72. Alright? As you can see, pH value is higher than 7. It tells us this is a basic solution. And at the very beginning, when we talk about the reaction equation, we said you have a basic solution at equivalence point. It should give you a pH value higher than 7. So based on our calculation, it confirms our prediction. Okay, so our calculation is correct. Alright, I hope this video can help you understand this weak acid base titration a little bit better. Again, please ask me if you have any questions.